In this program, we will examine how art and science interface. We will discuss TV special effects, photography, neon, and a brand new artistic technology, copy art. Nothing looks more real than a movie. And yet, like all art, the cinema also plays with illusion. Very early on, filmmakers were interested in special effects. Some effects, like backdrops, trapdoors, or objects attached to invisible wires, were taken directly from the theater. Others were a creation of cinema itself. For example, the camera could be stopped momentarily, and objects or characters would disappear. Or superimposing two images, the classic illusion was achieved. Split personality. Today, another just as impressive form of magic is emerging, that of television. Walking on a rainbow, observing how foods are irradiated, visiting a haunted castle, watching time pass, exploring the inside of a cell or the ruins of a temple, traveling through space. Television today offers creators a wealth of technical possibilities where the only limit is their own imagination and their production budget. Essentially, the basic principle allowing them to create images like these lies in the possibility of superimposing images from various sources. These compositions, designed down to the tiniest detail, are put together in electronic editing rooms. Here, such diverse visual elements as scenes shot on location or in studio, computer graphics, drawings, or simply black and white graphics can be superimposed, deformed, slowed down, or speeded up, colored or decolored, placed at will in the television frame, or transported. The type of machines required to create visual effects are videotape recorders. Their number can vary, but you have to have at least two in order to put two videotapes from different sources together. These are called the source or master video players. Another videotape recorder, the video editing recorder, is used to record the final composite image. The images on the master video players are first sent to an apparatus that constitutes an electronic editing room heart, the switcher. With a video switcher, dozens of combinations of images are possible. For instance, two images can be faded into each other, fitted together according to various geometrical designs, with clear or imprecise edges. A switcher can also generate shapes, color them, or animate them. Besides mixing the images from the videotape recorders, the switcher can also add signals emitted by a character generator. This generator, similar to a computer, is controlled by a keyboard. As a rule, it is used to produce titles and credits, but it can also be used to create geometrical shapes. Whether letters, figures, or shapes, the signals are relayed to the video switcher, which can, as it does with the video player images, change them 1,000 different ways. One of the most intriguing machines in modern editing rooms is the electronic image manipulator. This device can place whole images onto chosen trajectories for the desired time and in the 3 axes of space. It includes in its program an impressive number of special effects, so images can be twisted, solarized, multiplied, or made to burst. Like all the other machines in an editing room, the image manipulator is controlled by the switcher. The switcher sends images to it from the video players, the character generator, or a camera. The manipulator fiddles with the images and sends them back to the switcher, which, according to the whim of the operator, can add a final transformation before relaying the composed image to the video editing recorder. One of a switcher's most interesting functions is key insertions. Key insertion enables a creator to insert a person or an object into a real or fictitious setting. There are two types of key insertions. Chroma keying will isolate an object or a person from the color background on which it was recorded. And key in will place landscapes, objects, or decors into that color background. The second type of keyed insertion is called luminance key insertion. What's used here is the difference in luminosity between various surfaces of the image. For example, the white surfaces can be pinpointed and isolated by the switcher, which then replaces them with an image from another source. A computer called an editor coordinates all the machines used in an editing room. The editor controls the starting and stopping of the various machines, as well as the duration and synchronization of the various commands. With the recent advent of numeric editing videotape recorders and memory blocks, the number of visual elements that can be manipulated and juxtaposed in the same scene has become virtually unlimited. Both television and the cinema owe a great deal to photography, which was the first to be able to fix images. Photography originated from the dark room, or camera obscura. A dark room is an airtight box closed off to all light. On one side of the box, a little hole is pierced. The image of everything outside the box in front of the opening is projected inside the box on the opposite inner side. A little later, a means was found to fix that image onto a support, and that was the birth of photography. The 20th century may well be labeled the century of the image. In the streets, our houses, at work and at play, we are constantly bombarded by thousands upon thousands of images that may move us or solicit us, but that seldom leave us indifferent. The origin of this visual deluge we owe to a well-known image reproduction technique, photography. Unwittingly, the inventors of the camera managed to reproduce one of the most complex organs in the human body, the eye. The photographic camera and the eye have much in common. The function of both these instruments is to create a reduced and inverted image of an object, a scene, or a person, and record that image. The camera body corresponds to the eyeball. Both are dark rooms, completely sheltered from the ambient light. The camera lens corresponds to the lens of the eye. Both pick up light reflected by an object. Both are adjustable and will focus on an object no matter how far away it is. The lens aperture of the camera is similar to the iris of the eye. Both are mechanisms that regulate the amount of light that flows into the darkroom. When the iris contracts, it prevents glaring, and when it dilates, it enables nocturnal vision. The aperture, for its part, is essential to avoid over or underexposure of the picture. The eye's iris is alerted to changes in the intensity of light by the sensitive cells of the retina. These cells relay electric impulses to the brain. Similarly, a photographer is informed of these changes in intensity of light by a sensitive cell that also transmits electric impulses to the camera's electronic brain. Whereas the human eye is always open, the eye of the camera opens for only a brief moment, since it only records a fixed image. Often, the speed of the shutter can be controlled, enabling the photographer to freeze a movement or, conversely, give an impression of movement. The eye and the camera have one last thing in common. They both have the capacity of recording and revealing images formed. The eye uses the retina, and for the camera, it's film. The retina cells relay their signals to the brain through nerve impulses. The film records its images through chemical reactions. Most films are made up of silver salts, which have the property of turning black when exposed to light. These salts are combined to form microscopic crystals that are evenly distributed in a fine coat of gelatin. Every molecule of silver salt is connected to an atom of bromine, chlorine, or iodine. Even though the silver is black, when associated with these chemical elements, it becomes colorless. When you take a photograph, some of the silver salts in the crystals that are exposed to the light are chemically dissociated. Thus, a black metallic silver forms in crystals exposed to the light, whereas non-exposed crystals remain intact. An image formed by the exposed crystals and the non-exposed crystals then forms on the film. For the time being, though, that image is invisible. In order to see it, the film is submerged in a chemical substance called a developer. The developer finalizes the conversion of the exposed crystal's silver salts into metallic silver. However, the developer does not react with non-exposed crystals. This results in the formation of a real image. That image is called a negative, since the lighter areas of the photo show up dark, and vice versa. The final stages in the development are fixing the image, or ridding the film of non-exposed silver salts that might blacken in the light, and washing it. The negative obtained can then be reversed and enlarged on a paper whose chemical composition is similar to that of film. Thus, the original image is perfectly restored. From this basic principle, a great variety of types of film have been made. Color films, for example, consist of 3 photosensitive layers, respectively sensitive to blue, green, and red. The developer reacts with pigment present in each layer, generating highly complex shades of color. The same principle applies to the eye. To distinguish colors, the eye also uses 3 types of cells, respectively sensitive to blue, green, and red. This would indicate that Mother Nature, in her infinite wisdom, invented the principles of photography thousands of years before man. Some artists take an avid interest in scientific discoveries as they happen. Shamelessly, they pillage everything technology has to offer. Electricity enabled sculptors to design objects that move. The laser gave birth to holograms. By the end of the 1930s, the neon light had been integrated into works of art. And recently, copy art took hold. Light has always been a special material for artists. By using light and its properties, artists can create atmospheres, stir emotions, and convey messages. Most recently, artists have discovered new ways of using light. One way is through the use of fluorescent tubes, more commonly called neons. To make a fluorescent tube, the artist begins by heating a long glass tube with a Bunsen burner in order to give it the shape he wants. He then attaches 2 electrodes at the ends of the tube. The electrodes are covered with materials that will emit electrons when heated. One of the ends has a small opening so that the tube can be connected to a vacuum pump. Air is withdrawn from the tube and replaced by a rare gas under reduced pressure. That rare gas may be argon or neon. Whereas an incandescent light bulb uses heat from a tungsten filament to produce light, a fluorescent tube works according to 2 other physical principles. When electrical tension is applied to the 2 electrodes, they heat up. The negative electrode then transmits an electron beam to the positive electrode. Some of these electrons come into contact with the atoms of gas in the tube. Every time this occurs, the gas atom loses an electron for a brief moment. It then becomes a positive ion, but the ion is unstable. As soon as a new electron comes into contact with it, it picks it up, thereby becoming a neutral atom once again. This phenomenon results in an emission of light. Artistic interest in fluorescent tubes is based upon the fact that you can not only change their shape, but also their color. For instance, a neon tube gives off a red light. Conversely, an argon tube emits a blue light and a variety of invisible ultraviolet rays. These basic colors can be altered by using tubes coated with phosphorus, a chemical substance that radiates visible light when exposed to ultraviolet light. This phenomenon is called fluorescence. By varying the contents of the tube and the phosphorus that coats it, the artist can create a rich palette of colors. Besides using light directly, artists can also use it indirectly. One of the most original approaches, copy art, consists of creating works of art from a simple office machine, a photocopier. The heart of a photocopier is a belt or a rotating drum coated with a photoconductive material. In the dark, the photoconductive materials will build up and store electric charges. However, when exposed to light, they lose their electric charges. When you make a photocopy, an invisible image of the original, composed of electric charges, first forms on the drum. This image is then developed by a powdered ink, whose fine charged particles are deposited on the drum. Finally, the ink is transferred onto a previously charged sheet of paper. The laser color copier uses a series of primary color inks. In 4 luminous sweeps, each color is successively deposited on the drum, then onto the paper. By combining them, you can obtain a wide variety of shades, and therefore a faithful copy of the original. This device also has many artistic possibilities. For instance, starting with an original copy, a drawing, a photo, or even a slide, an artist can create a whole range of different images. He can alter or reverse the colors of the image, stretch it one way or the other, reduce or enlarge it. But copy art artists go even further. A new artistic approach called computer video consists of subjecting images to a series of transformations using advanced computer and electronic techniques. For example, they will record a scene or an object with a video camera. The image is then digitalized, that is, translated into computer language. This computer is equipped with a software program that enables the artist to modify the image at will. The transformed image can then be picked up by a printer or a camera. Finally, the picture can be reproduced on a photocopier using the color play and superimpositions possible in this machine. The final result, a far cry from the original, is truly a work of artistic creation. It's easy to imagine that if Leonardo da Vinci were alive today, his works would incorporate video and film. New technology stimulates artists' imaginations. What could be more normal? For is it not in the very nature of the artist to be in the vanguard of all change?